Hey buddies, so basically in today's GFG POTD we have a problem, second largest, and it is basically a easy level problem. And as a problem given here, given an array of positive integer r, return the second largest element from the array. If the second largest element doesn't exist, then we need to return -1. Here there will be note, the second largest element should not be equal to the largest element. Okay, so basically as the example given here, so here this is the first example which is given as input array is equal to 12, 35, 1, 10, 34 and 1. So as we can see here in this particular example, the maximum element is like 35 and the second largest element is like we can say 34, so here it will return 34. But in this case, if we are talking about array, say in the second example here, the first largest element is like what, 10, but the second largest element is like also 10, so we don't have to consider the same element which is having the maximum values. That means here we have to count only one time. Okay, let's suppose if 10 is the maximum element, then we don't have to count this. Then the second largest element will be 5, so here we have to return 5 as an output. So the largest element of the array is like 10 and the second largest element is 5. Similarly, if we are talking about this element, so if we are talking about third example here, our maximum largest element is 10. Now if we are going to check another number, here the next number is also 10, and we have already know that we don't have to consider the same number. We have to check for the second largest element. So here all the numbers are same, so here there will be no any second largest element, so here we have to return -1. So here the expression is given, the largest element of the array is 10 and the second largest element doesn't exist, so that's why here it is like returning -1. It is like Arjun SAP Labs and Rock Stand, and it is like based on array searching, data structures and algorithms, and we need to solve this problem with an expected m complexity of order of n and expected auxiliary space of order of 1. So basically this is a very much easy problem. Here we can solve this problem by using, first of all we have to traverse it, and then after that we need to check for the first maximum element, and then we need to check for the second largest element. Okay, so first of all, for solving this problem, first of all we have to define, we can say that first max, okay, which we have to solve this test problem by using array manipulations, right? So here first of all we have to like define it, my first max by -1, and here second max is equal to -1. So initially we have to like declare two variables, first max and second max, to define this two largest elements, okay, and which we have to initialize with -1. Then simply we have to traverse it inside the array, and we need to consider for the first largest element. Okay, so here first for int I is equal to 0, I is less than, here is given, so here we need to traverse till the size of an array, and then I plus plus. After that, here we have to check if array of I, or if array of I is greater than first max, which is basically currently -1. So here what we will do, if array of I, let's say if we are actually traversing this side, so here we can say that yeah, 12 is traversing, we actually getting 12 by first iteration. So, and we know very well that 12 is like greater than first max, which is initialized with -1. So what we will do basically, first of all we need to take sec max and then first max. That means we have to store our all the values inside the sec max. So while traversing this and while completing all those things, while completing all those array, we are actually getting 35 as the maximum element, which we are actually storing. Let's say here we are saying that 35 will be stored in sec max. Okay, and inside the first max, what we will do, first max, here we will store array of I. Okay, like here we have to store our maximum element, and here we have to store the array. Okay, now we need to check for the second largest element. So here for that, what we will do, again we need to traverse it. No, here we don't need to traverse. Here we can do these things within same things also, like here we can write else if, and here we need to check else if, and then after that here we need to check for the another condition, like here we can say that if array of I is greater than sec max, and here we need to also check for the condition if array of I is not equal to first max. That means duplicates are not allowed. Okay, here we need to consider only for the second max element. Then what we will do, then here we can simply say that sec max is equal to array of I, which we have to simply return it. Okay, that means here we will get the second largest element. Okay, now we can simply return sec max. Let's try to compile and run. So yeah, our compilation is completed. Let's try to submit it. So it's submitted. So yeah, that's all for today. Thanks for watching.